In method 2 for simplifying complex fractions, I'll be looking at the same problems but using a different method. And so how this method works is we multiply the least common denominator of all fractions within the rational expression to each term, top and bottom, numerator part, denominator part, and then simplify. And this is my preferred method. It's, I think, quicker and easier for me, but you can choose whichever method you prefer. So let's use this method here. Here's the main bar. And so if you look at the numerator part, there's the denominator. If you look at the denominator part, there's the denominator. So I want the least common denominator of all the parts. So that means an x minus 5 factor and an x plus 5 factor. Those are unique and they appear at most one time. And so what I'm going to do now is I'm going to multiply those factors to all the parts of the expression. So I'm going to multiply that to the numerator part, x minus 5, x plus 5. And I'm going to multiply that to the denominator part. But I'm still multiplying to the numerator of that part, always. Okay. And then we're going to divide any of those factors that we can, cancel them out multiplicatively. So cancel those factors out. And then let's see what's left. In the numerator, we've got 6x times x plus 5. And in the denominator, we've got 12 times x minus 5. Then we want to see if we can simplify this any further by dividing factors from the numerator and denominator. And so since 12 is 6 times 2, we can divide a factor of 6. And that's all that they have in common. So let's go ahead and simplify what we have then. In the numerator, that's x times x squared. And x times 5 is 5x. In the denominator, 2 times x is 2x, and 2 times negative 5 is minus 10. So that's the simplified complex fraction. For example B, I'm going to be looking at all of the denominators in this expression, and I need the least common denominator for all of them. So let me start with a factor, let me start with x. Then the highest degree is 2. I need at most 2. And I have a unique factor of y. The highest degree is 2. I need at most 2 here. So x squared y squared is the entire least common denominator for this complex fraction. And I'm going to multiply that to each term of the expression. So the first term in the numerator part, x squared y squared. The second term in the numerator part, x squared y squared. The denominator part, first term, I'm going to multiply x squared y squared. And the second term in the denominator part, x squared y squared. Now I'm going to divide any factors that I can. For the numerator part, I can divide y squared completely for the first term. And that means that that first term is x squared times x. In the second term of the numerator part, I can divide one factor of y from the numerator and denominator, and that leaves 1 times x squared times y, so minus 1 x squared y. Then in the denominator part, I can divide x squared completely, leaving y squared times y, which is y to the third. And in the second term, I can divide one factor of x from both the numerator and denominator, and that leaves minus 1 times x times y squared. So, no longer complex, but might be able to simplify. So let me lock up my factors and see if I have a common factor for the numerator. Looks like, yes, I have x squared in common. So let me factor that out and divide from those terms. That leaves x minus y. In the denominator, is there a common factor? Yes, y with the lowest exponent, so y squared. Let me divide that to see what remains of those two terms, y minus x. And then again, I want to see if I can divide factors. So if I look at the x minus y and y minus x factor, I can rearrange those terms and then factor out a negative so that it looks very similar. So I'm going to take that negative and just put it in front of the y squared there for the denominator. So that's a negative y squared, and now the factor is x minus y. And I can go ahead and divide the x minus y factor to complete the simplification here of negative x squared over y squared. Whew, that's the simplified complex fraction there.